Good afternoon, everyone. It's a pleasure for me to be here at this workshop. Like I was just saying, it's very exciting these last couple of days, yesterday and today. And for me personally, I've been involved with Mars rover landing site selection going all the way back to Mars Pathfinder almost 30 years ago in 1994. And I got to say, it is really special to be involved looking for landing sites for astronauts. It's been a long time coming, so it's been for me exciting to see this. Next slide. Um, yeah, the next slide. The Artemis program is definitely real for anyone who has wondered about this. This past 5 months have been very exciting with the launch of Artemis 1 on November 16th, a successful mission, splashdown December 11th. And then the announcement of the crew on Monday of this week. And for me, I know Reed Weissman very well. We were finalists for astronaut back in 2009. And as life has it, he's going to be commanding the first mission back to the moon since the Apollo days. And I'm here talking to you about landing sites. But I'm very excited for my buddy. He's commanding that mission. It's going to be a great thing with the Artemis program kicking off with manned missions, human missions, I guess I should say. Next slide. I want to show you the context of the region. Everybody knows this slide. I have the Gerlache 2 rim site outlined in red there. And just a little bit about who this person was. Adrian de Gerlache was in charge of the Antarctic expedition. And his team was the first to ever winter over in Antarctica between 1897 and 1899. So this is who this crater is named after, de Gerlache. Next slide. Getting to the geologic context of the area. This is a beautiful image from the Kaguya mission some years ago showing de Gerlache crater. The de Gerlache Rim 2 site is on the back side of the crater rim, so I've got it approximately located. You can't see it from this view very well, but it's a great context view of the area we're talking about. The Gerlache crater is 32 kilometers in diameter. The whole regional topography people have been talking about today and yesterday has been obviously shaped by the SPA impact basin event in pre-Nectarian times, going back to the very early history of the moon. It's predominantly this region down here is feldspathic highland terrain we're talking about. And the Gerlache crater itself is Nectarian in age, and it slammed into this terrain down here. And the Gerlache crater obviously excavated material, deeper, older material, flung it up on the rim. And that's going to be a priority for sampling in this area down here. Is we're going to have access to some very old rock. And this place is heavily cratered like most of the sites down here. And so there's ejecta blanket on top of ejecta blanket, mantling the whole area. And there's younger impact craters scattered throughout here, and they're bringing up obviously older, deeper materials for the crew to have access to, especially Artemis 3 to go across the surface there. So one thing with these impacts, de Gerlache's impact into this older terrain, this pre-Nectarian terrain, we can encounter some purely anorthosite materials down here and impact melt in the area. So it's a very geologically rich area. But I think a lot of that can be said about almost all these sites down here. So like Jack was just alluding to, a lot of these sites have a lot of similarities. They're all interesting. And today, what I want to primarily do is just kind of put some focus on this site here, just so it doesn't get short shrift. I don't have a favorite at this point right now. They're all very interesting to me. Next slide. This is a geologic map. I think I've already talked about that. The chocolate brown material is the pre-Nectarian basin material. The yellow star is the landing site area I kind of just picked just to go through this exercise. And there is a crater up there, unnamed. It's about 8 kilometers in diameter. And there is a PSR in there. Now, there may be micro PSRs or ephemeral PSRs throughout these sites like most of the others, but I just wanted to focus on this one. This is the one that shows up in QuickMap. And you can see the Nectarian age de Gerlache crater below the star there. And I don't need to go through every one of these units here. I will mention, though, this crater, 8-kilometer crater that we'll be landing near the rim of, in Jim Head's talk yesterday, they mapped this as an Embryon age crater. So that adds us more geologic materials, ages through here, this area, this site. The next slide is kind of coming a little closer. It's showing where this crater and the PSR are in there. The topography is very kind for landing here. For Starship, you need to be slopes of below 10 degrees. And out in this area, the slopes are generally 3 to 4, maybe 5 degrees, very benign stuff. Also very benign terrain for walking across on the foot. It's kind of like rolling plains material. Next slide. Going in up, like I said, I went through and put down an actual, next slide. Yeah, here we go. I actually put down a 2-kilometer footprint because that's the maximum radius we expect the crew to get on foot during their EVAs. And so first of all, the PSR and that 8-kilometer crater is up in the upper right. We're not going to be able to get there with this mission, although I guess you could maybe nudge the landing footprint closer, and possibly the slopes down there are also not that bad. The slopes are typically around, at highest, around 15, 16 degrees going down to that PSR. Depending on where you measure it around the crater, sometimes they'll peak out around 20, but generally they're around 15 degrees. So it's not a nasty area to go in and out of. But I just think Artemis 3 is going to be very conservative. I'll allude upon that later. But the BF1 and BF2 are these boulder fields I'm going to show you better images with. But basically, this would be your area of operations if you landed here. And like I said, you can go through an exercise and put these 2-kilometer footprints everywhere. And even when we narrow down some regions, the 5 regions, there's a lot of sites still to work with. But anyway, let's just go. And there's multiple diameter craters in this area. The next slide is showing kind of the terrain topography. Pretty benign stuff. You can see it once again, maybe a little better here, the variety of small impact crater sizes scattered throughout this area that the crew could explore. And there possibly is a PSR in that darker area there, although it didn't show up in the quick map as a PSR, so I didn't label it as such on most of my slides. The next slide is kind of getting into some details about what the crew could hope to accomplish landing in this area. Once again, there's the capability to collect a diverse set of samples ranging from impact breccias, impact melts. These would be related back to the SPA Basin impact event. These would be pre-Nectarian, Nectarian age materials primarily. It'd be basically the remnants of the original highlands crust and any possible later intrusives in the area. I've already mentioned this pre-Nectarian is mapped that way. I don't want to. I know you can read slides, so I don't want to spend too much time reading every word on here. But basically, it's going to be a highly churned up, impact brecciated, thermally altered materials here from the heavy bombardment period of the moon. There's a good chance that we're going to be getting some definitely feldspathic highland terrain, so we're going to be getting that. And there may be some materials in here that shed the light on formation differentiation of the moon, particularly, the ancient, plagioclase rich crust there. Next slide. I think we've already hit on a lot of these things, so I'll just gloss over them kind of quickly. The crew will characterize, document, sample regional geology, to get better materials, better samples to bring back to get a better sequence of impact events in the area. Another thing is you'll collect paired samples kind of within and outside of PSR if you go into one, obviously. And this will be to characterize volatiles there. And also what you want to do with going these paired samples is do a geotechnical survey to compare what it's like inside and outside permanent shadow regions. Core entrenching regolith to assess, once again, going back to ISRU potential with the volatiles. Definitely going to take some core tubes, and some of this would be not only doing geology, obviously it's pretty obvious, but it's information there on the ancient solar wind trapped in the regolith. Hopefully, the science instruments haven't been selected, obviously, at this point, but a seismic station would be deployed, among other things. Next slide. What I'll do, I've talked about a lot of this, but I'm going to get back to the boulders primarily, because there's a lot of them here, and I think that would be the crew would make a beeline of these boulder fields out here. I mentioned already, there's a lot of craters here for doing radial traverse sampling. A lot of complex geology in the area to sample. It's going to help us figure out the surface and internal processes of the moon. And we have the volatiles in the area, these micro PSRs. To me, those may be everywhere from the stuff I've read. I'm not an expert in that area, but they could come and go in a lot of these small craters down here. But the main PSR in that 8-kilometer diameter crater is will be a permanent one. Let's go to the next one. I think I've already talked about that. Here is kind of showing you some images of these boulder fields I've been talking about forever, it seems like. But the image in the lower left, the white arrow is pointing to a boulder about 17 meters across. Some of these things are very large here. You can maybe make an argument this is an ejecta block that's breaking apart and weathering in place here. Other places, these boulder fields, I don't think they're a single block. They're just ejecta material. But there's a lot of this stuff here, and this would allow us. To me, these are optimal EVA stops. You're going to want to get to at least one of these boulder fields, if not both of them, for this site I'm talking about. You're going to have some good possibilities, boulders being pure anorthosite or deeper lithologies have been excavated from the massifs down there. And one thing about that with boulders sampling large things is you get a suite of rocks, especially if they're breccias, and it's a grab bag sample kind of. And it's going to, from scattering boulders versus picking up individual class in the regolith, boulders are very advantageous. And I think there's a person there on it, Jack, can tell you about this better than I can because he's actually done it on the moon. Boulders are great targets because they can be breccias. They preserve the presence of textures and fabrics.
Yeah, less than 1 minute, please.
Okay, let me go through. Okay, I'll zip through that. Let me summarize the slides. I've talked about the Apollo 14 mission. I think this is kind of a good analogy for what Artemis 3 will do in terms of EVA distances. Last thing I'll talk about in 25 seconds is mobility. And Jack talked about this earlier. Mobility, if you go to the second to last slide, and my slides are posted, so if you want to look at them in more detail, the other boulder fields. But mobility is a no-brainer. It increases your science capability. Artemis 3 may not have a rover, probably won't, but the science definition team definitely strongly recommended having a rover there if at all possible. And I'm going to stop right there because I'll be on time. I got 4 seconds. So 4 seconds over. Okay, I'll shut up then.
Pretty close, though. All right, thank you so much.